Great, thank you, Tamara, and thank you everyone for the time during this meeting to talk about this project. I'm really excited to have this chance. Just sharing my screen to show that I do exist as a real person and not just a voice in a screen, but or I should say my video. So this is what I look like in real life, but I'll turn that off to avoid distraction, but I look forward to any discussion during or at the end. So with that, this project was a effort undertaken in partnership with our state partnership committees, which is a portion of the FEMC. But the goal here was to assess how risky different trailheads are for introductions of different types of plants based on user behavior and where people are coming from. So this is a collaboration with Colin Byer and DEC to develop this information and extend some work that had been done previously. Some quick background on the Forest Ecosystem Monitoring Cooperative. We are a cooperative effort to provide information on trends and status of forests in the region. And we do this by providing some unique, nimble, high quality analytical and monitoring services to take issues that are being faced by states in the region now and providing fast turnaround projects. We take a pretty broad view of what constitutes a forest ecosystem. So yes, it includes the trees and vegetation, but also the drivers of change in that system, such as air pollution, or the responses such as soil chemistry or wildlife populations. So this is a pretty broad scale effort, but always centered on forests in the region. And we do this through three major types of work. First is on the ground monitoring of the ecosystem. We have a forest health monitoring program that's in Vermont and Massachusetts and will be expanded to the region soon for annual forest health measurements. We monitor drivers like air pollution or water flow, and we look at responses such as amphibian populations or avian demographics. So this on the ground monitoring is a key component of being able to have that baseline of information to track change over time. We also support a collaborator network that brings together people across disciplines and other organizations. And really the goal is to connect the management and research community together. So we do this through an annual conference that usually happens in Burlington, around 300 people from the region getting together to share the latest information on trends or status, and then as well topic groups around, say, soils monitoring, and our state partnership and steering committees where a lot of the work is done on our regional and state level projects. And the final area where we do support the cooperative is through this data archive access and synthesis, and that's really where this project falls. We maintain a fully featured data archive for sharing research and monitoring data with the broader community. We develop products and data-driven tools off of the data in that archive and do new and novel analysis or synthesis when requested. This is our team. We've been growing a little bit, so it's nice to have to shrink everyone's pictures because it used to just be 4 of us. So we're getting a little bit bigger, but this is a group of folks who are working on this work here in the region. And but we have a much larger network. So I think, yes, we have 10 people working full and part-time on this, but we also have a much larger network of cooperators who work with us on these projects. And this invasive risk project is an example where we had some really great help from Dr. Byer here in New York. So the goal of this project is to quantify the risk for spread to trailheads of invasive plants. The theory being that hikers transport plants and propagules around the region on their boots, in the treads of their car, in the fur of their dogs, and this movement of propagules from one place to another can lead to establishment at trailheads and then challenges down the road. And the Adirondack Park, as I don't probably need to tell anyone there, is a regional draw for quite a large catchment of states. It's not hard to get to from quite a distance and from quite a radius around. So there's lots of people coming into the area and recreating, as well as a lot of recreation from the areas around the park. And we were taking on this project to expand on some past work and go a step further. So this is drawing off of work that was first done by Colin Byer in 2014, expanded with some GIS analysis by David Rockefeller in 2016, and then finally really delved into by Abby Larkin in 2017, I think all at SUNY ESF. So they had originally focused their work on looking at trailhead registers and invasive species populations for visitors from New York and 7 focal plant species. You can see the species along the bottom there. This work took that same resource and looked further out to look at the 9-state region that's within a reasonable driving distance of the park, and looked at 96 invasive plant species and repeated that analysis. So this is really kind of an expansion and update of what they had done before to give us a much maybe fuller, more nuanced picture of risk. So the way this worked is we, so I should say, Colin and his students digitized trail registered data. So they went around the state and collected and scanned paper trail registers for all of 2012. And from those 217 registers in the park, there was another related study that looked at how much compliance there was. And surprisingly, a very high level of compliance with people who were visiting and also signing the trail register. So they found that 95% of people visiting Adirondack Park trailheads were signing the register. So they have all of this data. It's over 150,000 records. You can see a stack of registers that needed to get digitized for the park. And the team went through and previously went through and digitized the number of visitors in the party and the date and length of stay for every row. And then for every 5th row, they would digitize the town of origin, but they only really assessed or tried to map the town for New York at that time. So that means that of all the data that they had, they're only analyzing 20% of it for origin. So it's still quite a number of records, but certainly not the full stack there that you see on the left. So one of our first tasks was to take that origin data and go outside the state, and this involved matching up people's perceptions of where they lived or how they chose to spell their region, if they chose a county or a town or just a general part of the state. As best we could, we matched it up to municipalities in other states using administrative codes so that we could crosswalk that with the locations of invasive species data. But we also looked at how far people are coming. So we calculated travel distance just to get a sense of effort that people are putting in to visit the park and understand where the hotspots of visitation are coming from. So travel distance is calculated from town to town using from town to trailhead using established road networks to get that travel distance and proximity analysis done. The other significant amount of work that we did was to, again, go from 7 species potentially propagating from New York and look at 96 species propagating from 9 states. So we worked with 3 data resources, IMAP Invasives, EdMaps, and iNaturalist to extract research grade observations of invasive plant species in those 9 states. So we worked with whatever data was available and used that as the presence would indicate a potential risk of transmission for hikers coming from that town or municipality. So we compiled data resources from each of these, crosswalked the species to a standard if that wasn't already done, and created this master data set of invasive records. And I should point out this was done for the year 2012. So we wanted to match the visitation data to the invasive species data. The next step was to develop a ranking system. Sorry, there is a question in the chat. Since the 2 Canadian provinces neighboring, why weren't they included? That's a great question. We were looking for something that we could do kind of pretty quickly, so we were focused on the US purely for ease of analysis, but certainly an area that could be expanded as people coming from Quebec are much more likely to present a challenge than people coming from Pennsylvania, or probably a lot more people coming from Quebec before the pandemic. So the ranking system looked at the number of invasive species observations in each town by the number of visitors from each town to that trailhead. So we can combine this, we could develop this exposure score based by species and by town. And that could then be scored up by town into an overall risk exposure potential per species per trailhead. To deal with the wide variation in scales, this is log transformed, and that creates what Dan and Abby called the transfer risk potential score. And that basically is how likely is it, or how risky is it that a species is going to get transported to this location based on all the people who visited this trailhead. So it's comparable across trailheads, and it's aggregating across invasive species, or so you can calculate it across all invasives or just for particular invasives of interest, and we did both. So looking at some of the findings from this, we looked at time, July and August is peak use, again, probably not surprising. Significant deviation at the Adirondack Fire Tower register. So that is definitely the most popular, but you can see that the variation is pretty all over the map. Like the number of, if you look at the scale on the left, the percent of visitation is never that high. So the visitation is spread out quite significantly across the region and over time. Using this newly digitized trip origin information, so we analyzed additional 54,000 records. 90% of them are still in New York. So 9 out of 10 visitors are still coming from within the state. You can see the urban hotspots jumping out on the right-hand side. And the remainder are coming from Vermont, Pennsylvania, New Jersey, most often, less so from Connecticut, New Hampshire, Maine, or Rhode Island, but not in significant numbers. Using all of the invasive species data plus the origin data, we could identify those plants that pose the greatest risk of transfer. Some of them don't match the 7 key species that were previously analyzed, probably for reasonable reasons. I think about Norway maple as something that is pretty prevalent in most communities, but probably not something that we're as concerned about propagating just because of the seed size. The garlic mustard is scoring at 0.66 means. This is on a 0 to 1 scale. 100% of trailheads are being visited by people coming from areas infested with or with known observations in 2012 for garlic mustard. Lower score for purple loosestrife, but still a percent of trailheads at risk is 99%. Other species of interest that jump out at me are the common buckthorn, Japanese honeysuckle, and to some extent autumn olive. So this is our kind of composite, how risky is it by species, like which species are presenting the most risk to all the trailheads together, because there's so many different origins that have them. Looking at just one, such as garlic mustard, we have 100% of trailheads at risk. This is scaled, showing the registers as dots, and the coloring is the transfer potential. So this shows you where we have visitation occurring from areas of infestation at the highest levels, and thus presents the highest risk within the park. If we then flip this around and look at composite risk by trailhead, this is a breakdown of the trail registers that have the highest mean score across all the different species. So Johns Brook Lodge far and away exceeds the others, and 87 of the 96 species are have a potential transfer based on where people are coming from. But the variability is quite large. A 0.2 standard deviation is pretty big. So this ranges from very low likelihoods to very high likelihoods, as you can imagine. And then you can see some of the other trailheads that jump out as being particularly at risk for some sort of invasive species transfer. So these are just this is all the all in our report. The data is accessible, so you can grab the full report, underlying data sets. the scripts at the project page on our FEMC website. It's listed down there, or if you search ADK invasives on our website, you'll find it. So this gives a kind of overview of the methods in more detail and the underlying spatial data as well. And this, I think, could be really used more as a potential surveillance tool. So we have a couple web apps that people can use to explore the findings. We took the 10 plants of highest risk. You can access a story map or format that allows you to easily scroll through the different plants and see what the relative risk at each trailhead is and get some information on kind of the composite scores. And then you could also look at just all species and for each trailhead kind of filter down to which attribute or which species you're interested in. So those two maps are available for use as maybe a potential screening tool or as a potential advocacy tool if you need to explain kind of why managing visitation related to invasive plants is important. Looking ahead, we have wrapped this project up. It's what we call a sprint project, so it's supposed to be pretty short, but there's certainly more directions that we could go. I mentioned this is 2012 data, so we could, we talked about doing some more digitization of recent registers so that we could provide an update, like how have things changed between 2012 and 2019, but the amount of effort just to compile the Adirondack Park trail registers was a significant amount of work. So that would take some effort, and I know DEC is doing some of that, but we, as far as I understand, it's not, they're not digitizing the origin information, just the number of the party and the length of stay. So there would be some more work to extract that information from the paper, but you could use that to update our travel information. You could update the species, the invasive species data more easily and say, take the 2012 travel patterns and apply 2019 distributions. So if you assume that travel patterns are similar in 2019 that they were in 2012, you can map how people are coming to the region and what the invasions are that are more likely or more potentially impactful now as opposed to 7 or 8 years ago. And then finally, looking at the high-risk trailheads, either for introduction by any species or introduction of certain target species, you could begin monitoring those trailheads more intensively or undertake some sort of initial surveillance to see if there have been any introductions in the last 8 years of those highest risk plants. So those are all options for either more desk work or some on-the-ground surveillance. Other bigger picture, we could look more at species-specific impacts. So there's some work out of the Northeast Climate Science Adaptation Center and the Risk Network to develop an environmental impact score for invasive species so that you could maybe scale these results to which ones would have the most deleterious effect if they were to make a transition or transfer. We could also do a broader intersection between management and research to look at where the areas of greatest need for management are based on additional criteria. So yes, we have the transfer potential, but there might be other management criteria around demand management, parking, whatever, that could intersect. And so taking this data and doing some additional analysis with those management recommendations or concerns could be of interest. So there's certainly a lot of directions to go. Our goal was to enrich the data, add more origins, digital origins, expand the number of invasive species and the region from which those invasive species could come, and then rescore those trailheads by risk. So that's the output of this project. With that, I want to thank Colin and Abby and Dan for contributing and the actual original data and also continuing to guide this project as we went through it. And the FEMC staff who've put this together, Ali Kasiba, Matthias Search, and Emma Tate did a significant amount of work on the compiling and scripting to make this happen. And then Alyssa Shute for the preparation of the presentation and additional outreach materials she's been putting together. And finally, our funding comes from the USDA Forest Service, Vermont Forest Parks and Recreation, and University of Vermont are our main funding partners, and additional ones are starting up this year from across the region. So I want to thank all of them for contributing to the FEMC and making this work. So with that, I am done, and I will keep this up here, but look in the chat for any hands or questions or